This is the title of the quiz question. I'm focusing on understanding how the RBFSampler in Sklearn works. It's about a technique used to speed up machine learning. This is the main question. I need to carefully evaluate each statement and determine whether it's correct based on my understanding of RBFSampler. I will use my knowledge of machine learning techniques to select the right answer. This statement says that after using the RBFSampler with 50 components, the result will have 50 features. I need to check if that's correct given how the RBFSampler transforms the data. It's about the output dimensionality. This statement says the number of features will increase after using the RBFSampler. I'm comparing the number of features before and after applying the transformation. The RBFSampler often increases dimensionality. This statement claims the RBFSampler transformation is a linear operation. I need to know the nature of the transformation performed by the RBFSampler. Whether it's linear or nonlinear, it is about the type of transformation itself. This statement claims that the transformation approximates a Gaussian kernel, also known as an RBF kernel, and mentions a parameter called gamma, which controls the width of the Gaussian function. I'm examining if the RBFSampler does this approximation. This is specifying the initial dataset. I'm noting that the data starts with 10 features. This indicates that I am using the RBFSampler with a parameter in underscore components set to 50, meaning it will produce 50 features. It describes the transformation process. This indicates the resulting data will have 50 features after applying the RBFSampler. I'm confirming the final dimensionality of data. This is the final output after the transformation. I'm presenting a multiple-choice question about Sklearn's RBFSampler, a tool for kernel approximation in machine learning. We'll explore how it transforms data. This sets the stage. We're using RBFSampler, radial basis function sampler, with 50 random Fourier features to approximate an RBF kernel on a dataset with 10 original features. We'll examine several statements about the transformation's impact. This statement is true. RBFSampler, with 50 components, outputs data with exactly 50 features. It's that straightforward. This is also true. We begin with 10 features and end up with 50, meaning the dimensionality has clearly increased. Surprisingly, yes. Even though RBFSampler approximates a nonlinear RBF kernel, the actual transformation itself is a linear projection. It uses random weights to project the data into a higher dimensional space, which is a linear operation. This statement is true. RBFSampler specifically targets Gaussian kernels. The gamma parameter, bandwidth, controls the width of the Gaussian function, influencing the approximation's smoothness. While not explicitly set by the user, it's implicitly determined during the feature generation. I see RBFSampler as a tool that cleverly transforms data. It takes your initial dataset and changes it to make it easier to work with for machine learning. This transformation is key to speeding up calculations and improving the performance of your model. Think of it like prepping ingredients before cooking. You make the ingredients easier to work with. This tells us how the transformation happens. RBFSampler is short for radial basis function sampler, and it uses a specific number of components in its transformation, which is 50 in this case. It means the transformed data will have 50 features and each feature is a combination of original features, making this process efficient and meaningful in machine learning. It's like changing your 10-ingredient recipe into a 50-ingredient recipe with similar overall taste. After using the RBFSampler with 50 components, your data is now represented using 50 features. Each of these new features is a combination of the original 10 features, but cleverly created to approximate a radial basis function kernel. Despite the fact that the RBFSampler approximates a nonlinear function, a radial basis function kernel, the transformation itself is a linear operation. This means that we're just changing the scales of and combining the original features in a linear way, even though the final result models a nonlinear relationship. Think of it as mixing paints. Even if the resulting color is complex, the act of mixing is linear. The RBFSampler is designed to approximate a Gaussian kernel, which is a specific type of radial basis function kernel. This means that using it creates an approximate representation of a Gaussian function. It mimics how a Gaussian kernel would handle your data, allowing for faster calculations without losing too much accuracy. A Gaussian kernel is a bell-shaped curve and RBFSampler approximates that curve using random features. We start with data having 10 features. Think of these as different characteristics that describe each data point. These original features are what we want to transform. I start with a dataset. It has 10 features, which are individual measurable properties of the data points. Think of it like describing a person with 10 characteristics: height, weight, age, etc. I use scikit-learn's RBFSampler. It's a tool that cleverly approximates a complicated mathematical function, the RBF kernel, using a simpler method. I set n_components equals 50 meaning I want the output to have 50 features. These are the initial characteristics of the data points in my original dataset. I'm using these features to model my data. For example, after using RBFSampler, I get a transformed dataset. Now, each data point is described by 50 features, instead of the original 10. This is the new dataset after applying RBFSampler. It's the result of the transformation, with each data point now having 50 features. Even though the RBFSampler approximates a nonlinear function, the process of transforming the data itself is linear. That's a key point. It's like taking a curved line and approximating it using many small, straight line segments. RBFSampler approximates a Gaussian kernel. A Gaussian kernel is a type of function commonly used in machine learning to measure the similarity between data points. It uses a parameter called gamma, bandwidth, that controls how wide or narrow the bell curve is. The RBFSampler implicitly determines a gamma value during its calculations. We're using a tool called RBFSampler from the scikit-learn library to approximate a kernel function, which is a core part of many machine learning models. Think of a kernel as a way to measure similarity between data points. RBFSampler helps speed things up. After using the RBFSampler with 50 components, your data will have exactly 50 features. That's because RBFSampler transforms your data into a new space with a specified number of features. Yes, because I started with 10 features and ended up with 50, the dimensionality, the number of features, has increased. Think of this like adding details to a sketch. It makes things more complex but can also provide a better representation. Even though RBFSampler approximates a nonlinear function, the actual transformation it applies to the data is linear. This means it simply involves multiplying the data by weights and adding constants. It's like taking a photo. The process itself is pretty straightforward, even if it's capturing a complex scene. RBFSampler focuses specifically on Gaussian kernels. Gamma, which is implicitly chosen by the algorithm, controls the width or influence of this Gaussian. A smaller gamma means a narrower focus, while a larger gamma means a broader one. It's like adjusting the focus of a camera lens. A narrower focus emphasizes details, while a broader focus shows the bigger picture. This is the original number of features in my dataset before applying the RBFSampler. This is the scikit-learn function used for approximating the RBF, radial basis function, kernel. It's a technique to make kernel computations faster. RBF stands for radial basis function, and sampler indicates that we're using random sampling techniques. This is the number of features my data will have after I use RBFSampler with 50 components. This is the new dimensionality. I'm using scikit-learn's RBFSampler to approximate a radial basis function kernel. The ncomponents parameter, set to 50, tells the RBFSampler to use 50 random Fourier features for the approximation. Think of it like creating 50 new, cleverly designed features from the original data to represent the nonlinear relationships. I start with 10 features. After using the RBFSampler with 50 components, I end up with 50 features. That's a clear increase in dimensionality. The transformation projects my data into a higher dimensional space. The output of the RBFSampler will have exactly 50 features because that's what we set ncomponents to be. Even though the RBFSampler approximates a nonlinear RBF kernel, the transformation itself is a linear operation. It uses random linear projections, it's like rotating and scaling the data, to transform it. It's a clever trick to get speedups while dealing with the nonlinearity of the RBF kernel. The RBFSampler works directly with a Gaussian kernel. A Gaussian kernel is also known as a radial basis function, RBF, kernel. It measures similarity using a bell curve, depending on the distance between data points. The GAMMA parameter, which is implicitly determined within the algorithm, controls the width of this bell curve. I'm starting with a dataset that has 10 original features to describe each data point. This refers to the process of using RBFSampler to transform the original data to a new feature space with a higher dimension. The result of the transformation, a new dataset with 50 features.